Hey everybody, it's Miss Berry. In this video, we are going to go over section 6.4, which is called Logarithmic Properties and Models. All right, so I'm going to go ahead and share my screen and we'll get started. Okay. All right, so logarithmic properties and models. We are going to focus more on logarithmic properties in this section. We have already learned 3 properties of logarithms, which let me remind you what those were. The first property that we have already learned says that log base A of 1 is always 0. So regardless of what the base is, log of 1 is always 0. We also learned that log base A of A is equal to 1. So again, if the base matches the argument, they cancel out. You just have 1. And then building off of that last one, if you have log base A of A to some power R, then again, if the base matches the argument, they cancel out and you're just left with the exponent, which here is represented by R. All right, so we already learned those 3 properties of logarithms, and now we're going to learn 3 more properties that have names. So these are the 3 properties. This first one is called the product rule. So this is the product rule. Then we have the quotient rule. And then we have the power rule. These 3 properties are really important for helping us solve logarithmic equations. So it's important that you know how to apply these properties and when to apply them. So the first property, the product rule, says that if you have log base A of x times y, then you can separate that into log base A of x plus log base A of y. All right, so if it's a product, you separate it with a plus. The quotient rule says if you have log base A of some quotient, x divided by y, then that's equal to log base A of x minus log base A of y. So those 2 rules are very similar. The only difference is that here we have a plus, here we have a minus. The last one, the power rule, says if you have log base A of x to some power r, that you can bring that power or that exponent out front, and you can have r times log base A of x. So this is a great way to get things out of the exponent whenever you're solving logarithmic equations. All right, so let's look at some examples where we're going to practice using these properties. There's going to be 2 types of examples that you'll see in this section using the properties of logarithms. The first example is going to be where you have to expand expressions. So you are given a single logarithmic expression and you're asked to expand it as much as possible. And it says to simplify any numerical expressions that can be simplified without a calculator. Okay, so again, that last sentence here just refers to these 3 properties here. Okay, so let's do this example. We have log base 3 of 9x squared. All right, so here we have a product. So we have 9 times x squared. So we're going to use the product rule to separate that or to expand that. That becomes log base 3 of 9 plus, because it's product rule, log base 3 of x squared. Okay. So I'm going to come back and work on this in just a minute, but the first thing I need to do, or the next thing I need to do, excuse me, is I need to get rid of that exponent. All right, so I'm going to bring this exponent outside of its logarithm. Notice that it's not coming all the way to the front. It's just going out in front of its individual logarithm. So we have log base 3 of 9 plus 2 times log base 3 of x. Also wanted to point out that the log base 3, that stays every time. So the base is not changing. According to the product rule, the base is supposed to stay the same throughout, and then same with the power rule. All right, so just want to make note of what we did here. On the first one, we used the product rule. And then we used the power rule to bring that exponent out in front of its logarithm. All right, and the last thing I'm going to do is I'm going to work on this term here. So log base 3 of 9. I know that I can rewrite 9 as 3 squared. Everything else is going to stay the same. All right, and then I can use my properties of logarithms that I learned in the last section, which tell me that if my base matches my argument, those guys are going to cancel. And you're left with just 2 plus 2 times log base 3 of x. Notice that I didn't write the little dot for multiplication there. That's totally fine. It doesn't make it incorrect to write the dot. That's, either way is fine. That's my final answer. I cannot expand that anymore. So once you have just a variable as the argument in your logarithm, you know that you're done expanding. You cannot expand that anymore. All right, let's look at another example where we need to expand. Here we have log base 2 of 11x squared divided by y to the 6th. So I can see my first thing I'm looking at here is I got to deal with this fraction. So I'm going to go ahead and use the quotient rule to expand that. So I have log base 2 of the numerator minus log base 2 of the denominator. So again, just apply that quotient rule that told me if I have log base a of some quotient, x divided by y, it's just log base a of the numerator minus log base a of the denominator. All right, I'm going to come and work on this second term in just a minute, but the first thing I need to do is look at this term. I have log base 2 of 11x squared. I can go ahead and use the product rule to break that up or expand it. So that would become log base 2 of 11 plus log base 2 of x squared. Whoops, log base 2 of x squared minus, now let's work on this one. Or actually, we'll come back and work on that one in just a minute. Sorry. Okay, now let's look at what we have going on. Log base 2 of 11, that's in simplest form. Nothing I can do there, so go ahead and just rewrite that. Here I can use the power rule to bring that exponent out front. So go ahead and use your power rule to bring that out front. So we have plus 2 times log base 2 of x minus, I'm going to do the same thing on the last term. I'm going to use the power rule to bring my 6 out front. So that becomes 6 times log base 2 of y. And that's it. I have all I have left inside of my arguments here. I have a number, the number 11. I cannot rewrite that as 2 to some power. And then I just have my 2 variables here with no exponents, no coefficients. So I know I'm done. I've expanded this as much as I can. All right, and then our last one, part C, is natural log or ln of 2x squared plus 5x plus 7. All right, so your first instinct here may be to write ln of 2x squared plus ln of 5x plus ln of 7, but that's not correct. This is wrong. The product rule, which allows us to separate logarithms across addition, only applies whenever you have a product inside of your argument. Here we have the sum of some expressions or some terms, but we don't have a product. We don't have anything that says like, for example, ln or natural log of 2 times x squared plus 5x plus 7. If we had something like that, we could separate it by the product rule, but we don't. So there's nothing we can do here. This is already expanded as much as it can be. So this, we'll say this is already, or we'll just say cannot be expanded. Cannot be expanded. Sorry about that little squiggle there. So this cannot be expanded because it is not a product, it is not a quotient, and it is not a power. So we do have terms within the expression that are products and have powers, but the entire expression itself is a sum. And we do not have a rule for separating logarithms across sums. So there's nothing we can do. All right, so this is the second type of problem that you'll see. We have just done some examples where we were expanding logarithmic expressions. Now we're going to be doing the opposite. So we're going to be condensing logarithmic expressions or trying to write them as a single logarithm. It says, use the properties of logarithms to condense the following expression as much as possible, writing the answer as a single term with a coefficient of 1. All exponents should be positive. All right, so here we have a really basic one, 2 times log of x to the 4th. All right, so we're sort of using the rules in reverse this time. So if you have a coefficient out front, we know that the power rule tells us that that coefficient can go inside of the argument, and it becomes the exponent. So this would become log of x to the 4th squared. All right, we have a power to a power, so go ahead and simplify that. That would be log of x to the 4 times 2 would be 8. And you're done. We've written the answer as a single term. We have a coefficient of 1. Exponents are positive, so we're done. Let's look at one that's a little bit harder. We have part B, says 4 times log of x cubed y squared plus 2 times log of 1 over x minus 2 times log of y. So the first thing you want to do is the power rule. So go ahead and get those exponents, or excuse me, get those coefficients and move them inside. And they'll become the exponent. So go ahead and move all these coefficients inside. So we have log of x cubed y squared all to the 4th power plus log of 1 over x squared minus log of y squared. Okay, go ahead and simplify these exponents. We have log of, I'm just going to distribute the exponent here. We have powers to powers, so we're going to multiply them. That's going to be x to the 12th, y to the 8th, plus, that's going to be log of 1 squared over x squared. We know that 1 squared is just 1, so we can erase that. And then nothing to do here. This is already, the exponent's already simplified. Okay, now we're working left to right. First, just look at these first two terms. We have log of x squared, y to the 8th, plus log of 1 over x squared. We're going to use the product rule here to combine these guys. The product rule tells us that, let's go back and look at it. If you have log base a of x plus log base a of y, that you can combine those into a single logarithm and they become a product. So the arguments here become a product. All right, so let's do that. Our arguments inside of our parentheses are going to become our product. Whoops, sorry. So it's going to be log of, and again, in order for this to work, they have to have the same base. We can see these are both common logarithms. So again, we're going to multiply our arguments here. So we're going to have x to the 12th, y to the 8th times 1 over x squared. minus log of y squared. All right, so let's work on this and then we'll take care of this second term here. We're going to combine these so you can rewrite this as a fraction. You could do x to the 12th, y to the 8th over, sorry, my 8 looks a little wonky there. Let me try that again. I'm trying to write in a straight line, but struggling. X to the 12th, y to the 8th over x squared. Again, just rewriting this second term, log of minus log of y squared. Right now I can simplify this. We have 12 x's, take away 2. So that leaves me with 10 x's. Okay. Minus log of y squared. All right, now we're going to combine these guys into a single logarithm. So we're going to combine these guys into a single logarithm. Right now they are separated by a minus. So according to our properties of logarithms, that means we're going to use the quotient rule. It says if you have log base a of x minus log base a of y, that's the same thing as log base a of put x as the numerator, y as the denominator. So this first expression or this first argument is going to become our numerator. The second argument becomes our denominator. So we have log of numerator is x to the 10th, y to the 8th. Denominator is y squared. Go ahead and combine like terms. We have 8 y's, take away 2. That means we have 6 left. So we have x to the 10th, y to the 6th. Perfect. And that's it. We've condensed this down into a single logarithm. We've got a coefficient of 1. Our exponents are positive. I'm trying to make that look more like a 6. Somehow I made it look even less like a 6. Let me rewrite that. Y to the 6th. That looks a little better. So again, we can tell that we're done because we have our answer written as a single logarithm. So we went from having 3 logarithms down to 1 logarithm. We have a coefficient of 1 out front, and all of our exponents are positive. Right, part C, we got some natural logs on this one. It says, again, directions tell us to use the properties of logarithms to condense the expression as much as possible. You should write your answer as a single term with a coefficient of 1, and all exponents should be positive. All right, so go ahead. First thing you're going to do is use your power rule to go ahead and bring those coefficients inside the argument. We have nothing here. Sorry, my arrow was kind of going the wrong way. All right, so we have no coefficient here, so nothing to worry about on that first term. I like to do cursive L's so they don't look like ones. All right, so we have natural log of 14 plus natural log of x to the 8th minus natural log of y to the 6th. Start with your first two working left to right. And we have a sum here, so that means we're going to use the product rule. Our arguments are going to become a product. So that's natural log of 14 times x to the 8th minus natural log of y to the 6th. And again, in order for us to use all these properties of logarithms, all of your logarithms need to have the same base, which they do here. We know that natural logs have the base of e. All right, now we're combining these two into a single logarithm. This is going to become, this is quotient rule since they're separated with a minus. This is going to become our numerator. This is going to become our denominator. So we have natural log of 14 x to the 8th over y to the 6th. And that's it. Okay. The last thing we need to talk about before we end the video is what's called the change of base formula. This is important, and this is used if, so we're going to say important for situations where you need to evaluate a logarithm that has a base other than 10 or e. All right, so we know that log base 10 is called our common logarithm. Logs base e are called our natural logarithm. So this formula is going to be used when we are trying to evaluate a logarithm and we have a base other than 10 or e. And this is how the rule goes. It says log base b of m equals log of m over log of b. So this is the common log. You can replace this common log with a natural log if you want to, but I think this is the most straightforward way to do it, is just to look at one of them. So we have log base b of m. So regardless of what the base is, you can use a common logarithm to figure out or to evaluate this logarithmic expression. It says that log base b of m is equal to log of the argument divided by log of the base. All right, so let's look at some examples. It says evaluate the following logarithmic expression. Round your answer to 2 decimal places. All right, so I'm gonna open up my document camera here. You can see my calculator. Okay. All right, so we have 5 times log base 8 of 15. We need to go ahead and use the change of base formula here. So we'd have 5 times log of the argument divided by log of the base. All right, so 5 times log of 15 divided by log of 8. We're rounding to 2 decimal places, so that would be 6.51. Now, I just learned the other day, some of you may already know this, but I just noticed this the other day when I was looking at the calculator, that if you go to the math menu and you scroll way down, this is on a TI-84 Plus, that you have this function in the calculator where you can plug in any base for a logarithm. So you could use this if you wanted to. You could do like 5 times log base 8 of 15. Same answer. All right, and then again, if you have the TI-84, just to remind you, you have this little menu that you can access. If you go to alpha y equals, has this little fraction menu, and you can type in your fractions that way. So you could type in like 5 times log of the argument divided by, whoops, press the wrong button, log of the base. Sorry, I'm not looking where I'm typing. I keep hitting the wrong button. So just wanted to remind you of that little fraction button that exists in the TI-84 calculators. Our last one is log base 1 over 7 of 0.748. So again, the way the change of base formula works is you say it's log of the argument divided by log of the base. All right, so log of the argument divided by log of the base. And there you go. Rounding to 2 decimal places, that would be 0.15. Whoops. And again, if you have the TI-84, you could just go to the math button, scroll way down where it says log base. So log base 1/7 of 0.748, same answer. So again, these TI-84 pluses, and again, this is the TI-84 plus CE, so that may be, unique to this particular calculator. But you can check on your TI-84 if you have like the TI-84 Silver Edition and see if that's in there. Also, let me just mention this really quick and then we'll be done. If you have this TI-36X Pro, you can also evaluate logarithms with any base. And the button, it actually doesn't even say it, but it's right here. It's right under the second button. Let's see if I can focus this. Turn on the light. All right, so if you press this button right here, see if I can point to it. Right here, if you press it 3 times, 1, 2, 3, it lets you plug in any base for your logarithm. So again, you could do like log base 1/7 of 0.748. Same answer. All right, so if you have this TI-36X Pro, they also can evaluate logarithms of any base. All right, so that's it for section 6.4. If you have any questions about this section, please let me know. Otherwise, I'll see you guys soon.